Alright guys, let's go ahead and go over this homework. So, first things first, we have a car. Let me change the color here. Okay. Alright, so a car traveling at a speed of 20 meters per second and has a mass of 1,200 kilograms. So let's go ahead and solve this. We're going to write down our givens first. So we have KE, we have mass, and we have velocity, right? So this one is not giving us KE, so we know we're looking for this. And mass, in this case, is 1,200 kilograms. And my velocity is going to be 20 meters per second, okay? Again, make sure we know our units. Our units are super important. They're what's going to actually help us kind of know where everything's supposed to go, right? So let's plug everything in on this side. We have KE equals, I'm gonna go ahead and change that 1/2 to a 0.5 just to make it easier for me to like plug into my calculator. I know when I was like doing a lot of math in like high school and middle school and stuff, I would often get confused whenever I had to like plug in a fraction. So I just like had memorized all the decimal equivalents of like all the common fractions so that I could quickly just kind of transfer it over. So if you're also like me and really bad at fractions, then that's just, you know, a pro tip. Anyway, side note, so we keep plugging everything else in. I have 1,200 kilograms and my velocity is 20, which is squared. So according to PEMDAS, the first thing that we're going to do is solve this. So what I'm going to do is going to bring everything down. So I keep my 0.5, my 1,200, and then 20 squared is 400. So I have 0.5 times 1,200 times 400. And my answer should be KE equals 240,000 joules. Okay, let's do this number 2. So on number 2, alright, so we have a year 11 pupil with a mass of 55 kilograms swimming back on the chair, falling off of it at a speed of 0.6 meters per second. Let's be green this time. Alright, so we have KE on this side, M and V again. Our KE, we don't know, one giant question mark once again. M this time is going to be 55 kilograms. And then my V is 0.6 meters per second. So let's go ahead and start plugging everything in. So we have a KE equals, and again, I'm just going to go ahead and change this to 0.5, make life easier. 0.5, my mass is 55. And my V is 0.6, and that is squared. So I'm going to get my calculator real quick. So I have 0.6 squared is 0.36. So I'm going to bring everything down. 0.5 times 55 times 0.36. And I'm just going to multiply everything straight across. So 0.5 times 55 times 0.36, and that gives me a kinetic energy from falling off of a chair of 9.9 joules, and this should be your answer for number 2. Alright, now let's solve the last one, and let's use, what color do I want to use now? Red, why not? Okay, so anyway, a runner with a mass of 62 kilograms running at a speed of 0.8 meters per second. So again, we're looking for our KE, so we don't know what that is. Our mass here is 62 kilograms, and our speed or our velocity here is 0.8 meters per second. Now let's go ahead and plug everything in just like we did earlier. We have KE equals, I'm gonna go ahead and change it. I was thinking about it for a second. I was like, let's go ahead. 0.5 m is 62, and our velocity again 0.8. Notice that I'm trying my absolute best to make this point a really big deal when I'm writing it down, because even like now, I'll often forget about a point or something, and that makes a huge difference in your final answer. So again, just make sure that you're really prominating things, if that's even a word. Is that a word? Well, it is today. But you're really making prominent the things that are really going to matter within your answer. So we're going to go ahead and plug in 0.8 squared is 64. So we have 0.5 times 62 times 0.64, and we're going to just multiply straight across. So I have 0.5 times 62 times 0.64 equals, and my KE for the final one is 19.84 joules. And that is your final answer. Let's move on to finding our mass. So we're gonna look at number one, the automatic door closing at 0.2 meters per second with a kinetic energy of 1.6 joules. This should look very, very familiar to you guys. This was a question from our worksheet from yesterday. So we have KE, we gotta find KE, we still gotta find mass, and we still need to find velocity. So our KE for this one looks like it's 1.6 joules. My mass, again, we're gonna make that really prominent, 0.2. Oh no, see, look, that's what I'm telling you. Even I messed that up. I was not paying attention. Don't be like me, be better than me. 0.2 meters per second. And we are solving for mass. Okay. I'm gonna change colors because I feel like it. And why not? Okay, so anyway, our joules, we have 1.6 equals, we're gonna go ahead and change that to 0.5 not meters. Mass, we don't know what that is yet. And then we have 0.2 squared. Just like before, what we're gonna do is we're gonna go ahead and solve right here for our 0.2. So 0.2 squared is 0.04. So I'm gonna bring everything back down. So I have 1.6 equals 0.5. Mass we don't know yet, and we now have 0.04. And I'm gonna go ahead and multiply these two together because we wanna combine our like terms, right? So I'm gonna go ahead and bring down my 1.6 equals, and then 0.04 times 0.5 is 0.02, and I still have mass here. Now I have to isolate my my letter, leave a letter by itself, right? So we're going to divide both sides by 0.02, and when I divide 1.6 by 0.02, I get 80 as my mass. So that should be your answer for number one when we're finding mass. Now let's solve number two. I'm gonna stick with blue here. It says a wind turbine blade with a kinetic energy. This is a big number, so I'm actually gonna put this down here. Looks like we have 104,040 joules, turning at 6 meters per second, and we still don't have that mass, right? Okay, so let's go ahead and plug everything into our equation. I may have to do this part down here just because the equation, the numbers are so big. So I'm going to do 104 0.040 equals 1/2 or 0.5. M, we don't know. Our velocity is 6, and that is squared. So, again, we're going to go ahead, PEMDAS, and fix that one really quickly. I'm not rewriting that again. So we're going to keep 0.5 down here. We're going to leave our mass right here. And 6 squared is 36. Actually, yes, I do need to go ahead and rewrite that down here. 104,040. I hope I did that right. Yeah, I did. Okay. And now I'm going to again combine like terms. So 36 times 0.5 is 18. So now I have 18m because we're pulling that down from here. And that is equal to that 104,040. And we're going to divide both sides by 18. Oh no, I'm running out of space. Okay. Anyway, so divide both sides. So I have 104,040 divided by 18 equals, and I end up with, let me change the color so you can actually see this. You end up with 5,780 as my mass. And this right here is your answer for mass. Solve for number 3. This also looks like a giant number, so let's do Christmas colors. Who doesn't love Christmas? Okay, so we have an airplane traveling at 75 meters per second. Let me just go ahead and put that here. 75 meters per second with a kinetic energy of, let's see, 843,700 joules. Double check, make sure our numbers are right, and yes. And we still don't know the mass. Oh no, mass question mark. Okay. I'm going to, again, try to squeeze all of this in over here in this little corner. So we have 843,700 equals 0.5. Mass is, we don't know. And my velocity is 75 squared. And we're going to do same thing as before, 75 squared, 75 squared. Whoa, 75 squared is, let me keep this 0.5 here. We're going to keep the M. 75 squared is 5,625. And we have 843,700. All right, and then combine like terms. So we have that giant number multiplied by 0.5, and we end up with 2,800. 2.5 M. And then our other giant number, 143,700, right here. Don't be afraid to double check your work, guys. I am looking at this oh so slowly to make sure that I'm getting every single number right, because I just don't want to get this wrong. Because I missed a number or something, or missed a decimal. That would be the absolute worst. So, anywho, we divide both sides because we want to leave, that m by itself. So we're dividing both sides by 2,812.5. And remember in science, guys, we only go as far as the hundredths place. So if it was one more digit after this, a 0, then we would keep that. But if it was 0, 1, 7, blah, 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 we're not doing all that. In science, we care about the hundredths place. It's just a cute little side note. But anyway, divide the other side by 2,812.5. And we end up with a mass being 843,700 divided by 2,812.5. Yep, this is exactly what I was talking about. So we end up with 299.98. So we're stopping right here. And that is our mass. Alright, so the very last type that we have to solve today is going to be for velocity. So I'm going to go ahead and put my numbers off to the side. So I have KE, M, and V. And I'm going to look over here. So we have the bus traveling through town with a mass of 5,040 kilograms. So I'm gonna go ahead and put that there. 5,040 kilograms. And a kinetic energy, again, 39 joules. I need like commas. There we go. Makes my life better. All right, so we have 493,900 joules, and we need to find our velocity here. So I'm gonna change the color because why not? So my kinetic energy, let's see, KE, we have 493,900 equals 0.5 because that's 1/2. And my M is 5,040 kilograms. And we're looking for our V squared here. All right, so the first thing I'm gonna do is I'm gonna go ahead and multiply these two together. So I have 0.5 times 5,040, whoa, 0.5 times 5,040 equals, we have 493,900, 22,520, and this is my V squared. And I'm going to combine like terms again, so I need to get this over here. So let's go ahead and divide both sides. Divide both sides by 2,520. 2,520, and that's my V squared. So we'll try that again. So 493,900 divided by 2,520, and we have 100. We have 195.99, and we're not done yet. So we need to find the opposite of the square, which is the square root. So we'll take the square root of both sides, and the square root is, we end up with 13.999. And remember, science only cares up till this point here. So we're gonna go ahead and round this whole thing up to 14 is the answer for V. And that's what you should have gotten for number 1. Phew. Okay, I think we're finally done with all the humongous numbers. So let's do this again. So a lift traveling up to the top floor of the Empire State Building with a mass of 4,200 kilograms and a kinetic energy of 4,116 joules. And we gotta find the velocity. I don't know why I sing when I talk sometimes. I apologize. So let's go ahead and fill these numbers in. So we have 4,116 equals 1/2 or 0.5 for those of us who hate fractions. That's me. And M 4,200. And V squared. We're just going to leave that alone there. So let's go ahead and put these two together, multiply those two. So we have 4,200 times 0.5, and that gives me 2,100. And then we still have my little V squared here. 4,116. And again, we want to combine like terms once more. So we're going to divide both sides. Well, I keep doing that. By 100 and 2,100. So now I have 4,116 divided by 2,100 is 1.96 for my v squared, but we know we're not done yet because we have to take the square root. So the square root of both sides, and that is 1.4 for my velocity. So I end up with 1.4 meters per second for my velocity for number 2. Made it! We made it to the last one. We can like do a little happy dance now. So if you're in my class, you'll notice we already did this number 3. But if you're not, yeah, let's go ahead and solve for number 3. So we have a kinetic energy of, whoops, that was definitely wrong. Let's try doing this in yellow. I haven't done that yet. So we have a kinetic energy of 40.5 joules, a mass of make the point, big deal, 0.25 kilograms, and a velocity of, I don't know. We're gonna come back over here. I think yellow is confusing to write with, to be honest. I'm just really partial to blue. So we're going to do 40.5 equals 1/2. We'll just go ahead and do our 1/2 this time because I haven't been doing that in a second. 1/2 m, which is 0.25, and v squared. So when I plug this into the calculator, times 1/2 times 0.25 gives me 0.125 v squared. I'm just going to bring those two down together, and then I have 40.5 here. And when we divide both sides by 0.125, remember, because we want to isolate this variable, 125, you end up with 40.5 divided by 0.125 is 324 equals v squared. And then we take the square root because that's the opposite of squaring, and we end up with v equals 18. And this is your answer for number 3 for solving velocity.